So for problem 2, a company manufactures 2 types of electric hedge trimmers, one of which is cordless. The cord type trimmer requires 2 hours to make, and the cordless model requires 4 hours. The company has only 800 hours to work and to use in manufacturing each day, and the packaging department can package no more than 300 trimmers per day. So let's go ahead and begin, as we always do, by trying to identify our totals. And so again, the totals are usually going to be the biggest number. And so I see that I've got the company has 800 work hours and no more than 300, can package no more than 300 trimmers per day. So we will say that our total is going to be 800 hours for work. And our other total is going to be 300 trimmers that can be packaged each day. So, as I've said before, we need to first, step 1 is identify our totals and label them. Then step 2 is going to be to find the other components and label them with an X value. And then find the second components and label them with a Y value, and we will fill those in. So let's go back and read again. A company manufactures 2 types of electric hedge trimmers, one of which is cordless. The cord type trimmer requires 2 hours to make, and the cordless requires 4 hours. So it sounds like we have a cord type and a cordless type. The cord type requires 2 hours, and the cordless requires 4 hours. The company has only 800 work hours, and so that means we cannot exceed that, so we need to be less than or equal to the 800 work hours. And the packaging department can package no more than 300 trimmers per day. And so it doesn't matter what type of trimmer it is, it takes them the same amount of time to package them. I'm going to assign the X value to the cord style, and so the Y value needs to go with the cordless. And so since it doesn't take a different amount of time to package them, and I'm actually going to change my name of this over here from trimmers to package. And so that's for packaging trimmers. There's no difference. That's going to be the same number, so we're going to have X plus Y. And we can't exceed the 300 hours for packaging, so it's going to be less than or equal to. It's kind of tricky when there are no numbers like that, but it's just you need to remember that it's because it takes the same amount of time for the cordless and the corded version, and so we can assume that those coefficients are just 1 on that second set of inequalities there. So now that we have our inequalities, if you need to write this down, pause the video because I'm going to move this off screen. Now that we have our inequalities, I can come over here, say new, and don't save, and I will get a new sheet here in GeoGebra. Again, I put in my inputs to X plus 4Y is less than or equal to 800. And I've got X plus Y is less than or equal to 300. Now again, everyone, if you make a mistake, you can easily turn one of these off by clicking that, or you can come over here and delete it using the 3 dots. Just a quick reminder there, and again, you can see I cannot see what is going on with the graph, so I need to zoom out. And if I have my arrow selected, I can grab in the white and manipulate this and move it around to kind of get a good picture of what I'm trying to see. So I'm looking for corners that are bound by the x-axis, the y-axis, and abut the dark purple region here. So in order to mark this corner, and this corner, I need to add a line here on the y-axis and on the x-axis. So as I've done before, I'm just going to duplicate these inputs and put in an equal sign so that they put a line on top of the inequality that's there. Then x equals 0 and y equals 0 to cover the x-axis and the y-axis. Then I come up here and grab my intersect tool, find the corners that abut the dark section, And we have those 3 points as solutions. And so again, all of these in here are options. Anything inside the dark section would be an option, but we are pushing the extremes by getting to these corners. We are making the best use of all of our resources by doing that. And so that's why those are the 3 best options for us, because it is making the best use of our resources. So again, for point A, we do have 0, 200. So this is saying to produce no corded hedge trimmers and 200 cordless. We have an alternative of producing 200 corded ones and 100 cordless. That's option B. And we have an option to produce 300 of the corded variety and none of the cordless variety. That's option C. And so that is it for the first part of this, everyone, where we are looking for inequalities that represent the scenario. We graphed it and we found the corners of the solution region. And now we need to know, we're trying to maximize sales or maximize profit. And so the company sells the corded model for $22.50. And so we need a profit function. It sounds more like a revenue function, but for the corded model, we're going to bring in $22.50 for every one that we sell, so 2250x. For the cordless, we're going to bring in $45, so 45y, because it's $45 for every cordless model we sell. And then our profit function, or probably revenue function in this case, I hate that we continue to talk about revenue because revenue doesn't matter unless you're considering it with cost, as we've talked about before. But we'll play along with this problem, is going to be 2250 x plus 45y. And so now our job, everyone, is to test each of those 3 points, A, B, and C, in that function to see which one of them is going to make the most money for our company. So 2250 in point A, x is 0, and y is 200. In point B, x is 200, and y is 100. And in point C, we see that we've got x at 300 and y at 0. So again, our job is to test each one of these and see which one produces the best result. So we'll bring Wolfram back into the scene here, and we will try our first one. We've got 2250 times 0 plus 45 times 200. And that's going to give us a profit of 9,000, or revenue in this case of 9,000. We also have the option of making 200 of the corded model and 100 of the cordless model. Interesting, that also produces a profit or revenue of 9,000. So both of those are equally good options. And lastly, we have the opportunity to produce 300 of the corded model and none of the cordless, which results in a revenue of $67.50. So we can obviously tell that option A and option B are both the best for this company. Before I write out my final answer, some people may be thinking, well, it looks like we could have split this 200 and 100 and made 150 and 150. And maybe that's better. Let's see what happens if we do split it down the middle and we do 150, 150. So this is interesting, everyone. It does come out to be 10,125. I do want to show you on GeoGebra why that is not an option. And so if we were to try and produce 150 and 150, you'll notice that we're at this point right here, which means we are outside the bounds of what is possible. So it is actually impossible to produce 150 of each because it is not inside this solution set. So if your boss was to come to you and say, hey, I did some math and it looks like we can make more money by producing 150 and 150 instead of doing one of these two options. You would be able to tell your boss, no, because you're not going to be able to produce 150 of each because you're going to run out of hours, or you're going to run out of, what was our other thing, packaging. Oh, you're going to run out of hours for production, or you're going to run out of hours for packaging. 150 is not a solution. It would have to be down inside this dark purple region to be a solution. So again, just reaffirming one more time, everyone, that these 3 points that we come up with when we do this are the absolute best and the absolute maximum. I'm not sure why my iPad's doing that. These are the absolute best and the absolute maximum for this scenario. So we have two options here for this company. We can say to maximize, what's the wording in this problem, sales, produce either 0 corded and 200 cordless, or 200 corded and 100 cordless. Both would produce the same result.